Students, now there is another video for you about the square roots and the cube roots. You know very well when two numbers, when a single number is going to multiply 2 times, means that it is square. We will write it like this: 2 square. Clear? And when a single number is going to multiply 3 times, then we will say that it is 2 cube. Okay. Here I just want to make you clear that the anti of the square is square root and anti of cube is cube root. Clear? And now I just want to make you clear that when the power is not in fractional form, when here look at here, when the power is not in fractional form, it is called index or power, and this one is called base. Here 3 is power index and 2 is base. Clear? And you know that the anti of square is square root. Because 2 is in power, its anti is square root, so its anti will be in power. The value of square root is 1 by 2 in power. The value of cube root is 1 by 3 in power. And you know that this power is not in fractional form, so that's why we are saying that it is index. This power is in fractional form, we will say it is radical. And this one is called radicand. Clear? Here 1 by 3 is radical and this one is radicand. Now this one is clear to you? Again, you know very well that the anti of square is square root. How can we use the square root? Listen that to remove the square we will take square root. To remove the cube, we will take cube root. How will we use it? Now I'm just going to explain the use of this square root. When you will face that 2 square here, and there is square root, how can they cancel with each other? Square will cancel with square root. Clear? 2 is multiplying with 2. Okay, 2 is repeating 2 times, so that will write is 2 square, and this square will cancel with the square root. 2 multiplied by 2 multiplied by 2, 2 is repeating 3 times, that is 2 cube. Clear? We will take cube root to remove cube. Clear? When we take cube root, then this cube will cancel with the cube root. Okay? Now I'm just going to explain the values of the radicals. Okay? When there is only the simple, square root, it is called simple root. It is called square root. Clear? Its value is 1 by 2 in power. And this is when there is the radicand is 3. When the radical is 3, we will say it is cube root and its value is 1 by 3. And when there is a fourth root, we will say 1 by 4, its power is 1 by 4, and so on. Okay, clear? This is the video. And also I want to make you clear that square always gives us area and cube always gives us volume, where the cube root and square root always give the length, and length is called the distance. Now there is question number 4. Topic is square root and the cube root. This question number 4 belongs to exercise 1A, exercise page number 13. Now I am going to just repeat the statement of question number 4. Given that the prime factorization of 9801 is 3 to the power 4 multiplied by 11 square. Now find the square root of this bigger one number without using calculator. Okay. It is very obvious that you are given by the prime factorization of 9801, means 9801 is given you in this question in factorized form. So there is no need to find the factors of 9801 like this by table method. There is no need. Okay, next. Before explaining this question, I want to discuss the properties of the square root with you. The properties of square root are when two numbers are going to multiply with each other, when there is a combined square root of these two numbers, they can be separated. But in addition, they can't separate it. Okay? Means combined square root of 2 plus 3 is not equal to, is not same as square root 2 plus square root 3. When two numbers are going to divide, there is a combined square root of these two numbers in fractional form. They can be separated in numerator as well as in denominator, but in subtraction they can't be separate. Clear? Means we can shift the square root individually in multiplication as well as in division, but not in addition and subtraction. Now I'm going to explain the question. You know that these two numbers are multiplying with each other, as we have read in the property that this square root can be separated, and as you know that we have to find the square root in this question. So we will write the statement as it is, and now we will take square root on both sides of the equality. It is also the property of the square root that you can take square root on both sides of the equality, and also this is the property of equation. Okay, now we'll take square root on both sides of the equality. Because 3 to the power 4 is multiplied by 11 square, by using the property of square, we can separate them. Okay, before separating that, you know that you are finding square root, and there is 3 to the power 4. Because you are finding square root, so that's why we will separate the 4. We can write 4 as 2 plus 2. And you know that there is 3 to the power 4. You can write 3 to the power 4 as. So we are writing it like this. 3 to the power 4, we can write with 3 square multiplied by 3 square. Clear? Again, we will combine them. We will get. So that's why by using this rule, we can write 3 to the power 4 as 3 square multiplied by 3 square directly, multiplied by 11 square. Clear? Now we will separate this square root by using the square root property, and you know that this square will cancel with square root, this square will cancel with square root, and this square also cancel with square root. Because powers are cancelled, so that's why 3 will remain as it is, multiplied by 3 will remain as it is, multiplied by 11 will remain as it is. 3 3 the 9 multiplied by 11, 9 multiplied by 11 is equal to 99. This is the answer of question number 4. Means the square root of 9801 is 99. We have to find that in this question, which is known to us.
Assalamu alaikum, dear students. Hope all of you are fine and healthy. May Allah bless us His mercy. Today we are trying to solve question number 3, exercise 1A, as our topic is square root and cube roots, and subtopic is prime factorization. We try to solve question number 3 of exercise 1A by the method of prime factorization. Here the question is, find each of the following by using prime factorization. A part. We have to find the square root of 1764. So first of all, we have to find the prime factors of 1764. Here we have a rough work, and we find the prime factors by using prime numbers, and here the prime factors are. Okay, now next, because we have to find a square root, so we make pair of the numbers, like 2 multiplied by 2, 2 square, 3 multiplied by 3, 3 square, 7 multiplied by 7 is equal to 7 square. Here we see that square is common in all the notations, so we take common 2 here, that is 2 multiplied by 3 multiplied by 7, and the square is common. Square and square root are cancelled each other, so here we have 2 multiplied by 3 multiplied by 7. So the square root of 2 multiplied by 3 is 6, 2 3 the 6, 6 7 the 42. So the square root of 1764 is 42. As part A, same pattern we used in part D. Here we have to find the cube root of 1728. So first of all, we must find the prime factors of 1728. So these are the prime factors, and we can write it as 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3 then multiply by 3, and so these are the prime factors of the number 1728. We can write it as our simplification. We can make 3 pairs like 2 multiplied by 2 multiplied by 3 times. So as we see that 2 multiplied by 2 multiplied by 3 is 3 times. So we can write it as 2 multiplied by 2 multiplied by 3 whole raised power 3. Here 3 and cube root must be cancelled each other. So we can write it as 2 multiplied by 2 multiplied by 3. 2 2 is the 4, 4 3 the 12. So the cube root of 1728 is 12. Okay, and your homework is question number 3, same as we done C and B and C part. So best of luck to your homework. Allah Hafiz.